Hello everyone, so this is the fourth and final uh, video on this deep excavation problem. So in the last session we basically did all the analysis and we have the construction sequence here that's very important, and we learned together how to do the excavation and how to activate anchors like that and how to calculate the factor of safety. I need to spend some good time with you now to see how we can interrogate the results. So basically, from anywhere, any phase here, you can just go view calculation results, and this will give you the output window. So this is the output, and it gives you uh, this view here, as you can see. So this how this retaining wall will basically form. Uh, so the final, if you are interested in the final one, which is excavation last, this gives you the full deformation pattern. You can show or hide the elements. It's up to you. Element contours. You can show mesh here element deformation contours, which is a nice perhaps pattern to show. And if you are interested in uh, anything specific here, so you start basically focus on it. Now, because of this structure member, which is a wall, I'm interested in this in that wall. So there are lots of ways to do that. If you choose this here, drag a window to select structure. So you just click here, and then you drag this window, and it will ask you, are you interested in the plate or the interface? So Plaxis consider the interface to be a structure. So I'm interested in the plate, so view the plate. So it has shown it to you. So it's telling you that this plate will deform maximum value of about 48. That's U. This is a total deformation, which is counted from the moment we zero the deformation, if you remember. If I'm interested in the lateral deformation, I can say give me UX. So this is a distribution of uh, I have a maximum value here of 45, 46 millimeter going into the excavation. If I would like to see what will happen to the vertical movement, so it will be moving down by about 15 mil here, and you can show this, show something like that. It means this point will move down by that magnitude. This point will move down by that magnitude. Again, if I go to UX and you are interested in a certain point and labeling, you can use any of those stuff here. Now, because this is a wall, I'm interested in the forces, so I can go to forces, say give me the bending moment. So this is the bending moment for this particular phase. If I need the maximum bending moment, or the moment envelope, so you press this one here, this is the envelope of the bending moment. So the maximum value here is 588, and this is a working value. Some people multiply this by 1.5 to get the ultimate value, and you give it to the structure engineer. And then if you're interested in the axial force, so this is axial force maximum, but you need to make sure if you come here and say maximum, it will give you the maximum for all the stages, all the phases that's above this one here and including this one. So you need to make sure to go to the last and then see whatever you're after. This applies also to the shear force. If you are interested in taking this into Excel, so you go to table and then it will give you everything, any minimum, any maximum, any Q, yeah, and so on. So this is where you interact with the structure engineer, to give you to decide whether these forces will be taken structurally by the structure member, be it pile here. Now, if I'm interested in the say earth pressure behind it, so you go here and say you go here, and you can choose this thing here and say I'm interested. Give me the interface. So the interface here basically is, if you go to deformation, mesh conductivity plot, it gives you this as as a line, and they say interface stresses, this will be sigma dash m. So this will be the distribution of the earth pressure. You go to the excavate last, so this will be the distribution of the earth pressure. It's very important that you can take this one outside, and you draw it in Excel. This will give you sigma dash n, pointer is sigma dash n, which is a lateral effective stress here, and you also can draw the K active, you can draw the K passive, and you can draw K naught to see really how this pressure would compare with the at rest pressure, for example. So this is how you can interrogate the earth pressure. Now I'm interested in the excess pore pressure. So stay excess pore pressure. Excess pore pressure, it means whatever pore pressure that will develop on top of the hydrostatic pressure. Because I have this layer only here, this is only an undrained layer, so I can say, give me the excess pore pressure here. Let us go mesh and just uncheck this one here. So you have here, as you can see, some excess pore pressure in the clay. Some has negative, which is in the contractive response, -46, and some other values also will have positive value. So if you are interested in excess pore pressure, so this is a hint window. You choose this one. If you go to any point, it's telling you in this window the values you are interested in. So it gives you the coordinate XY. You can see here I have XY, and it gives you the excess pore pressure and so on and so forth. So now I got this happily. If I'm interested in the, you can say structure here again, I'm interested in the, say, node to node anchor view. So this will give you the forces in the node to node anchor, as you can see here. So this is in the maximum value. You can use this here, and also you can choose if you are interested. You can choose again. Well, okay. Let us sing again here. You can use this. We don't want this anymore. Mesh and then this connectivity plot. If I'm interested in, say, the let's take this window here. Okay, I am. Well, it's not cooperating. Let us go back to this view calculation results. So you can basically again choose a structure. Let's choose this one. Excavate last. Choose a structure. Do this embedded beam view, and this would be the displacement. If you go to the axial force, so this would be the axial force in the grounds for each of the grounds. You can see here it tapers down as one would expect. So this would be the forces in the grouted part, and you can check it against the capacity. Now the results for each phase you can see here. That's each phase. If you proceed down, so it gives you the various phases of deformation, if you like. And if you want to see, by the way, if you see the fixed teeth, so they have fixed teeth here. So this roller supports, and it's pinned here. Like we said before, you want to see the phreatic surface. So this will be the phreatic surface. So you can happily interrogate the results. Now for completeness, you can go to the curve manager if you are interested in creating something. So in this project I had a node, if you remember. In this node I'm interested in, say, the lateral movement of the first node, which is the crest of the sheet pile, of the solder pile. So that's UX. And I would go to the sigma stage here, say, okay, I should be able to see a curve. So it has shown me a curve. It may not be very revealing, but right click, if you right click here, say settings, and you can see the phases, remove these phases, and I'm interested from the point, say, when we start the excavation. So, and I'm not interested in this because it's not real displacement for the factor of safety. So I say, okay, apply, and and now I have basically the values that happen with each phase. If you are interested in a specific phase, you can even separate it or take it to. So if I go to phases and I can deselect all, see what will happen in excavation one. So right here, you see this is what happens in excavation one. So the point has moved from 0 displacement basically for each phase here. This is sigma m stage. It means at 10% of the excavation, 20% of the excavation, 100% of the excavation. You see the point really moves gradually more into the excavation to reach a value here of close to, you can basically get this value here, it's 25 millimeter, as you can see. As you get close to the point, as you get close to the point, it gives you, and you can see here, it gives you mark like the maximum value or the minimum value for you, which you can control from settings, and then say, okay, this node, I can show the minimum value, maximum value. Watch what will happen to this. Say apply, so this point will either disappear or come back. Apply, so it will come back. And you can control the various features of this chart here in that sense. So, and if you say table, so it gives you everything here in table. Like I said, this column here is how much percentage of the stage has been taken, and then the corresponding value. Okay, so when I save it, you save it. Now, something that we have not covered here is basically the excess pore pressure inside. So low back stresses, pore pressure excess. So what will happen to this excess pore pressure over time? This is clay, and this has developed some excess pore pressure, and then one would expect over time that some consolidation will take place and the excess pore pressure will start to dissipate. I'm not covering this here, but it's something to keep an eye on. I may be able to cover it in a separate course, but the intention here is just for the beginners to show you something uh, you can do, and it's quite substantial project, and I hope you have. I'll see you in another video.